Hello and welcome back to the lab. Today on the bench we have an oddball. I am not 100% sure what this thing is, and well, I know it's a frequency counter, but I don't know what this part is. On this particular unit, I've been working with a makerspace down in Greenville, Tennessee. This is actually one of their units, and they asked me to just go through it and kind of check it, make sure everything was working, so that's what we're going to do today. They're setting up some basic electronics benches and some ham radio things for the community to use and play with. And because I have a couple of the standards and a few other things, I offered to just look through a little bit of their equipment and make sure it was on spec for anybody who was looking to use it. So the first one we're going to tackle is this Systron Donner Counter 1037 series. That doesn't say much, although some of the neat part is we have NASA stickers on here. So this probably dates around Apollo, maybe. Not quite sure. I do believe this is a Nixie tube display. We'll have to turn it on and confirm that. But I've been kind of looking at the internet for a little bit, trying to figure out exactly what this is and at least what speed it is. Like you'll notice on the front panel, there's nothing that says what speed this thing is. So I don't even know how fast this goes yet. Is it 50 megahertz? Is it 100 megahertz? Is it 200 megahertz? Is it 250 megahertz? I have a 250 megahertz counter in here. My main lab counter is a Agilent 53131A. So this would be redundant for me. But I do seem to be, I do kind of want some of this Nixie tube stuff because it's been coming into the lab and it really does look cool. That being said, let's get into this thing, see if it even works, and or doesn't work, and go from there. I was there when this was picked up. I was actually helping move this equipment. Some of the stuff that I got came from there, and we're kind of splitting up that equipment. I do have some 500 series scopes that are coming. Here's a future video. So we'll be rebuilding some 500 series scopes for them as well. We did save all of this stuff from the dumpster. That was kind of how I got involved real quick. If we had not gotten down there when we did, the scrappers were going to come next. So literally thousands of pounds of equipment was saved, and some of it's going to be gone through. I don't know what the plans are for all of it yet. We're still trying to work that out. Some of it's going to land in my lab, and we'll go from there. But we're helping getting them set up, and we did save a lot of stuff from the landfill. There was, I think there was 15 500 series scopes there. It was crazy. But we're gonna start with the counter. So let me get this hooked up to the isolation supply, and we will go from there. Okay, since we're doing a safe bring up, I have 4 bulbs switched in. Now I have 60 watt bulbs, which are about a half amp a piece. And the line's running about 122 volts today, so let's see what we do. It's trying, but I think our current limit is too bad, but the bulbs look all right. Let me give it some more power. Give it another amp. Yeah, it's looking like it's trying to work. All my displays are lit up. Everything's running. The line voltage is running about 88 volts, so I have a sneaking suspicion this thing's going to draw some power. But it's not shorted, so let's give it power. Oh, there is a fan. Fan's moving a little bit. Let's see if the knobs work. So this looks like it's going to be a slower. Wow, that fan's warm. That fan's spinning up. It's getting a little noisy. This looks like it's going to be a slower frequency counter because we have gate time, and this is in seconds. So we have 1, 10, 100 seconds, 1,000 seconds, 10,000 seconds, and 100,000 seconds gate time. So I'm not sure what this was measuring, but it's not on the faster side. Looks like we have a range. Really wish I had a manual for this. I'd like to know what HET is. And I have found absolutely nothing on this video amplifier, this 1948A. I have no idea what that's for, and I'm actually kind of curious. So if anybody knows, let me know in the comments below what the video amplifier was for in a frequency counter. Nice thing is it does have all the covering caps. Even on the back, these are covered. Let's see. Yeah, that's moving the decimal like it's supposed to. Megahertz. Yeah. This is probably the store and hold button. Trigger level. Let's throw a signal on it and see if it counts. Okay, so for frequency source, we're going to use the Rigol 2000. Since I've gotten the two Rigol function generators in the lab, I have not used the 2000 much. I definitely tend to go more towards the 4000, but let's see. We got 10 megahertz, 2 volts peak to peak. And let's just give it, see what it does. Oh, we're counting. And we're very close to 10 megahertz. I'm going to leave that run for a little bit and see what happens, but that is actually fairly impressive. One of the things you'll find with gear like this, especially since it's been well maintained, I'm sure NASA did not shortcut the maintenance. When the gear's brand new, the components will drift around a little bit. You'll get some plus, you'll get some minus. They'll kind of settle. As time goes on, they'll settle. Then you'll do a last calibration, and then you probably just have to check it for a while. Now this takes a significant amount of time in aging. We're not talking about 1 to 5 years, but some of the 7000 series stuff that I have, I'll check it every once in a while, but I may have done the last alignment when I got them ready for the bench, because they've already settled, they've moved what they're going to do. Now, that also means the environment, every piece of equipment is different and needs to be treated as such. You'll have 2 meters, and one will stay in cal, the other one will drift out. So it's just aging components. So it does still need to be checked and maintained, but the stuff does get easier to maintain the older it gets. So the fact that we are very close on frequency probably means this is not going to need much adjustment at all, and it'll probably stay stable for a very long time. Well, it works, so there may not be much we have to do with this, but let's crack it open, take a look on the inside, see what's there. This thing is built like an absolute tank. Here are the fuse caps. We have metal fuse caps covering the plastic fuse holder. They really don't build stuff like this anymore. We do have a selectable time base on the output, which is kind of strange. Normally you don't get this on the frequency counter outputs. We can go from 10 to -7 to 10 to the 9 in either time base or scaling. So not quite sure what you would use that for. We also have a big ribbon connector for BCD encoding out to a logger or something. And over time, we do have an NEC connector was fitted. This was for sure not a factory. This is a modification. But I've taken the 3 screws out of the lid, and it still won't move because they're clamped. I have to take these side clamps off the lid to get this open. So let me do that real fast, and I will bring you guys back when I pull the covers. Oh, we had a myriad of mismatched screws, but look at that. This is a solid aluminum sheet, and it even has RF shielding along the edges to keep the RF out and the RF in. So what do we have going on in here? Well, we have our fan here, which will probably need to service a little bit, maybe put a little bit of oil on there. It's moving, but not too bad. We have 4 bulk filter caps here. Our time base appears to be this block here, which is a Motorola part. This is the mains power transformer, which means this is going to be a linear supply and lots of big TO3 package transistors for the voltage. God, this thing's heavy. For the voltage regulators. So this is the plug-in slot. Here we can see they actually have every single power rail with its own fuse, which is way overkill. We have a board clamp, and then we have all these power modules here. Let's pop one of these power modules out and just take a look at it. Our Nixies are up here, and then yeah, we have decades. This is the 250 kilocycle decades, so 250 kilohertz and under. We have a 2.5 megacycle decade, a 10 megacycle decade, and a 50 megacycle decade. So this is probably a 50 megahertz counter. And then the time-based board. And we also have a multiply by 3 for 10 megahertz power supply. So let's take a look at the power supply and the time-based boards. Oh, that wasn't even an unscrew. That's a quarter turn and an unlock. Look at that. Oh, yikes. Yep. So we're going to get that cleaned up. That is 1960s foam, which did not age well. Just doing a quick spot check after I cleaned up all the foam, because I used a vacuum cleaner to do that. You got to be really careful with vacuum cleaners and this stuff. They can generate a lot of static at the tip. Obviously, static, especially in a device like this, is detrimental to say the least. It can take out a lot of the silicon, so you have to be really careful doing that. And they do even make some special anti-static vacuums, but when you have that much air moving through a plastic tip, it's just going to build up static. It's a big problem in woodworker shops. The dust collection systems can actually explode because of the fine sanding dust gets into the pipes and it builds up so much static. A spark goes off and it can pop a dust explosion. Don't be afraid of it, but be aware of it. It happens rarely, but it can happen. Okay, here's our power supply board out and exposed. I'm looking for burn discolored resistors. We have some very large power carbon comp resistors. I'm also looking to see if there are test points for the various line voltages, which I am not seeing. I would love to just check the voltages, but without a service manual, I got to find the test points. And at the moment, I do not see any test points, although I do have the set points, the 225 volts, 9, 9, 30, and 30. But I have no idea where I tap those off so I can actually set them, which is, I may have to pick up a manual for this thing. Well, I'm still trying to find a manual for this thing. There's 3 different edge connectors in this on 2 levels. You have a back one, middle one, and then a high one up here. The time-based cards use that. That is going into the Nixie board. So nothing on the power supply goes direct into the Nixie board, but I'm sure it gets there in other ways. These boards take some force to get out of here. But here's our time base. What are these? These are 74 series logic, 7490s, and looks like we have a date code of 52nd week of 66. Okay, so the SN 7490 is a decade counter, and this is a very typical time-based implementation. They're just set up in a string, and it counts, and then it does the next one, and that's how it gets the decades. And the 1966 year code would put this at very late Gemini, well, just at the end of Gemini, and very early Apollo. So this probably served in a lab somewhere during the Apollo missions, which is actually really cool. Let me pop out the 50 megahertz readout real quick, and we'll see what that looks like. Not much going on here, just some discrete transistors. I was thinking there might be a counter or something on this board, but it looks like we just have some discrete transistors for speed. But this whole thing is discrete transistors. Actually, those decade counters are the only things I've seen that are ICs. Everything else is transistors. And on this board, we have lots of 2N1304s, which are actually a TI part. Okay, well, it does not look like there's going to be much to do on the cards, since I'm not finding a lot of electrolytics. There was only 2 on the power supply board, which seemed to be well overrated for their position. So they seem to be all right. I do want to measure the ripple on the main power caps, but to do that, we have to flip the unit over and get at the bottom, so we can. I want to take the ripple measurement direct on those filter caps. And look at the bottom side of this board. So we have our power supply section over here, but these switch stacks, holy cow! You do not see stuff built like that anymore. That's incredible. I am going to service these up a little bit. The switch stacks don't need cleaning because they're actually sealed plastic modules. But I am going to check them for mechanical. I may put a little bit of lubrication oil on there just to kind of free up the contact, make sure it doesn't seize. A lot of the oils that were used back in this time period, they pyrolyze, and that's why the stuff can just lock up when it's not used. A lot of this gear, especially some of the stuff that I have to restore, it actually suffers from disuse as opposed from overuse. So we'll get that taken care of. It's not a big deal. Now that I've got the power supply turned on and everything kind of angried up, we're going to check these caps for ripple. I'm going to be exceedingly careful because does have tubes in it, so there is elevated voltages everywhere. That's going to be our 286 volt supply right there. Like I said, we've got some things spiced up. This one is 44. It's probably going to be the 33 volt rail. 43. There's a negative. Is that a negative 19? No, positive 19. Okay, positive 16. Okay. Now there's also regulators right here that I want to be exceedingly careful of. I don't want my hand to come down on these. So let's check these for AC. And I am doing all of this on the DMM 6500. But what I do want, I want a detector bandwidth of 3 hertz, and I do want to filter. Where's my power line cycles? I don't know if I can set power line cycles on AC. So actually, let me get clip leads. That will probably make this a bit easier, since the measurement is going to be slower. Okay, it looks like we have about 2-ish volts of ripple on the 300 volt supply. Change the clip lead. That's getting a little close to the case. Let's go for a bit smaller. We have about a 0.5 volt of ripple on there. half a volt. Now, it should also be known that this is coming right off of the transformer, or right off of the rectifier, so this is actually pre-regulator. Half a volt. So it's going to read a little bit higher. There we go, under a volt. So that's starting to look good. So power supply looks okay. Everything on the bottom side down here. These are all the sockets for the TO3 power, the power transistors for the regulators, and some of the regulators for this unit before they migrate over into the main board. Well, I'm going to let it run, see if this timing stabilizes, and if I need to adjust the timing a little bit, we will, but I think it's already starting to come down a bit, so I think it's going to lock in. I can't find anything wrong with this unit. Everything is running good. They certainly don't build stuff like this the way today as we did back in the 60s. This is an all-aluminum chassis, steel frame. Thing is built like a tank, probably weighs 15, 20 pounds. But it's still running, and I can't find anything wrong with it. So we're just going to let it go. I got it set up on the current limited power supply. We are going to let it burn, and as long as nothing else happens, this unit's going to be good to go. If you would like to do some measurements on this unit, on this particular unit, and you are passing through Greenville, Tennessee, there is a makerspace down there. I will see if I can get a link in the description down below. So I'm just going to let this thing do its thing, and I'm going to actually keep the frequency counter on it so it's counting, so I'll know if it errors out and quits, but I think this one's ready to rock and roll. Well, this thing's been counting away for several hours, and everything's been good. No hiccups, no nothing, no loss of stability, no anything. It's well up to temp by this point, since it's been running for about 6-7 hours. Nothing looks like it's overheating. Everything looks like it's behaving, and every once in a while, it drops one count, and then the very next time it counts up, it comes back. So, like right there, it's a little instability of the oscillator, but it is not enough to warrant adjustment. So everything is ready to go for this, and this is going to go into the done shelf, and we will get on with the next restoration. But this one looks like it's ready to go back. So, thanks for swinging by the lab, taking a look at the Systron Donner Counter 1037. And, as always, I will see everybody in the comment section, and more is always on the way. And with that, on to the next repair.